Welcome cosmic adventurers to the amazing world of the Universe Hope Games channel. I am your intergalactic guide, here to take you on exciting journeys through the most diverse virtual universes. I am, Hope, the supreme commander of this spaceship of entertainment. Get ready to embark on epic adventures, unravel cosmic mysteries and immerse yourself in gaming experiences that will push your boundaries. With each episode, we'll delve into new worlds, challenge our skills, and share moments of pure fun and excitement. So fasten your seatbelts and get ready to embark on this unforgettable space journey with me. May the force of gaming be with us all. I know where you reside in the universe. In reality, we all inhabit the universe. However, the concept of universe depends on the meaning assigned in the dictionary. The universe is everything that exists, that is, it is impossible for anything to exist outside of it. Everything that exists is part of the universe by definition, so the answer to what exists outside the universe is simply nothing. However, I can be more precise. You do not reside anywhere in the universe, but rather within what we call the observable universe. What lies beyond the observable universe is complicated. The observable universe is a narrower definition, as it encompasses everything that humans can see in some way, even if only hypothetically. So the observable universe is, in effect, everything in the universe that we can access in some way. What is outside the observable universe is what we cannot see. If you had a magic telescope capable of seeing any distance and pointed it at the sky, the maximum distance you would see would be approximately 40 billion light-years. Light is the fastest thing in the universe, yet it has a finite speed, traveling at a speed of 1 light-year per year. The light that reaches your eyes from this distance was emitted when the universe became transparent about 13.4 billion years ago, roughly 400,000 years after the universe began. Here a common question arises: how can the universe be larger than its age of 13.7 billion years? The answer is simple: space can expand faster than light. That's because the universe's expansion isn't technically a velocity, it's as if space is stretching and pushing distant things away. Nothing is being driven by an outside force. We live in a universe that is expanding. Most galaxies are moving away from us due to the expansion of the universe. Even the most distant galaxies we observe are moving away from us at nearly the speed of light. At some future point, the speed between us and these primordial galaxies will exceed the speed of light. This means that their light will no longer be able to reach Earth, and these galaxies will move beyond the observable universe. Therefore, outside the observable universe, there are more galaxies and stars, similar to the ones we have around us. Now the question arises: why is the universe expanding? Why are galaxies being pushed beyond the observable universe? The expansion of the universe is determined by the geometry of the universe, which is influenced by the constant tussle between gravity and dark energy. Gravity is the force that attracts matter and tries to stop the expansion of the universe, while dark energy does the opposite. It exerts a pressure that makes the universe expand, almost like anti-gravity. The relative amount of dark energy and gravity in the universe determines its geometry, which in turn determines how the universe expands and what will happen in the future. There are 3 possible scenarios: the universe is closed, flat, or in equilibrium. In the closed, gravity-dominated universe, galaxies, even the ones that are currently moving away from us, would eventually come back and approach each other again. That is, the expansion would stop at some point and all the matter would come together again. In the scenario where dark energy dominates, the universe would have a geometry similar to a potato chip, and the expansion would accelerate more and more, causing all galaxies to fall out of the observable universe. This scenario is quite sad. Finally, there is the equilibrium case, where the universe is flat and the expansion slows down but never completely stops. The universe becomes inert, cold, and with nothing interesting happening. Which of these 3 scenarios is correct? Based on what we can observe in the observable universe, the universe is flat and the acceleration of expansion will slow down but never reach zero. This is weird, as it's a perfect balance scenario with no good explanation. Scientists don't like precise things that don't have explanations, because they seem wrong. This raises the question of why the universe is so perfectly flat. One possible answer is that it may not be flat, and this conclusion was reached based on limited information. For example, in this room where I'm shooting this video, the Earth appears flat, as its floor has no noticeable curvature, and I can walk without falling. However, we know that the Earth is round, But this is a discovery of humanity made through more elaborate experiments, such as observations of shadows in different cities. Maybe the universe isn't flat, but the observable universe looks flat because it's just a very, very small part of the universe as a whole. Perhaps, if we could look beyond the confines of our observable universe, we would see that the universe is shaped like a big potato chip or even a cosmic donut. This view would determine whether the universe would contract again or expand forever. So the answer to what exists outside the universe is nothing, because by definition all that exists is our universe. A better question would be, what exists outside the observable universe? And the answer would literally be the answer about the future of spacetime. Thank you very much, and until next time.